Here's a very simple project made with the servo. In this box here, I've got a microbit inside connected to a servo, and I've got another microbit here that is measuring the amount of light that falls on the LEDs, and it just sends a number by radio to the microbit in the box, and the microbit in the box then interprets that number as an angle which it moves the servo to, and we can use that as a simple light meter. So if I get my microbit here and I move it close to the light, you should see the hand go up towards the sun, and if I put it back down on the table, you should see it goes down a little bit. And then if I cover the microbit over with something, put it in the shade, there we go, you can see it go down. It's taking readings about once a second because I don't want to confuse the servo too much in case there's a sudden change in light. Oh, there we go, I want to give it a chance to respond to that. You could use this as a kind of weather station because this is radio controlled. It could go outdoors and you could have a little meter inside to read on a little cardboard display like this how sunny it is. You could do the same for temperature readings. You can make a rain alarm as well. You could perhaps, if I can find it, I've done with it. I had a little flag here. Here we go. You could make a very simple rain alarm using the microbit touch pins. If you wired up 2 touch pins to bits of tin foil, when rain drops on them, perhaps you can make a little rain flag pop up so you could show indoors when it's raining outdoors. All sorts of things you could do with this. Very, very simple to wire up. Just a servo and a microbit in the box, and an external power supply, and the microbit here just with a battery pack sending numbers by radio. Right, let's have a look at the code that makes all this work now. So this is the microbit that's measuring the light level, and we'll have a look at the code that runs on that. When it starts up, it sets a radio group because it's using radio to broadcast numbers to the receiving microbit. So we set the radio group to number 23. You can pick any number you want. And we've got a forever loop, and it's running once a second. It's taking a reading of the light level from the LEDs on the microbit, and it's mapping it. Light level readings are 0 for very dark, and the brightest light it can read is going to give a value of 255. So we map that from 0 to 255. We map it from 0 to a height of 180 because they're the angles. I've got a 180 degree servo. So I'm going to transmit a number that is the angle to which I want the servo to move its arm when it receives a number. So that's the code that's running on the microbit. It's as simple as that. A very, very small amount of code. Over on the receiving microbit, looks a bit like this. A little bit more complicated because I've got some blocks in here to sort of calibrate the thing and when I set it up. So again, on start, it's got to set the radio group to be the same as the transmitter. So that number's got to match, but it can be any number you like. I've got some blocks here, when I press buttons A, B and A and B together, just to move the arm on the servo to a known position to 0 degrees or 180, just so you can set the thing up and calibrate it and physically glue your arrow onto the right bit of the device that's pointing the correct way and get all that lined up. So those are only those A, B and A and B button blocks are just there for setting the thing up. The only bit that really needed for making this work is the on start block here to set the radio group, and the on radio receive block. And all that does is it just turns the angle on the microbit on the servo to the number that it receives. This means this is a general purpose receiver. It can be used for anything. You can use it for signaling. You can set it for any angle you like. You could do anything. You could have different messages around here. You could make a rain alarm with it as well. So why have I used pin 16? That's the other thing. I've got pin 16 right only. Why use pin 16, not pin 0 or pin 1? Well, the reason for that is to do with the way that I've wired it up. So inside the box, if we open it up, you'll see there's actually not much in there. There is a microbit with a breakout box, and the back of the servo is gaffer taped on there. The reason I've used pin 16 is you might be able to just see there, I have discovered that if you've got this particular breakout board, it means you can clip on a servo little wire adapter pin block thing, can go straight on it. So you don't need to do any cutting, soldering, you don't need to mess around with wires and crocodile clips and things that are going to fall out. It gets a good solid connection. So if you go down the edge of this particular block, luckily in order it's got ground, it's got 3 volts, and then the next pin along is pin 16, which happens to be a right only pin, which means we can use that to control the servo, and we can connect it all together. So here we go. It's my self-contained light meter box. If I plug it in to a power supply, so I just plug it into some USB flavoured electricity. Here we go. Let's see if this works. And so I've got that's my receiver. Here's my microbit that's going to transmit its light level. If I plug it in, let's see if it works. So, battery connection the right way around. There we go. So there we go. Let's see if I make it sunny. Is it going to go up to sun? There we go. Sunny. Here we go in the sun. Oh, I've got a microbit pointed right in the light. If I take it away, going down. There we go. Fantastic.
We're sorry, the number you have dialed is not in service at this time.